Okay, this is the first day of angles. So we're going to talk about the vocabulary associated with angles. We'll be able to name angles, and we're also going to introduce the angle addition postulate, just like we had the segment addition postulate. Angles are made up of two rays, if you notice. Okay, rays have a start point. For angles, the start point is always at the vertex, and then they point off in different directions, and those rays form the sides of the angle. Okay, so each angle always has two sides, and the sides are rays. Those rays meet at the vertex. The vertex is where the angle kind of turns. There's an interior part. Okay, that's the green part here. That's the interior of the angle. It's what's between the sides. And there's an exterior, which is outside of the angle. Now we can measure angles. Okay, so I'll show you how to do that right now. Okay, so we have a protractor here. Okay, so when you're measuring angles with a protractor, this part right here, the T, okay, the T right there, that's what goes on the vertex. Okay, some protractors have a T or a crosshair or just a hole on there. That goes right on the vertex. You want to make sure that one of the sides is lined up with the 0. So on this one, the inside number is my 0. That means I'm going to use the inside numbers to measure the angle. Okay, so this one looks like it would be about 35 degrees. Okay, using the inside one. Now I can line it up the other way. Okay, so now the other side of the angle is my 0 line, and 0 is on the outside now, so I would use the outside numbers to measure the angle, and this angle is 35 still. Okay, so that's how you use your protractor. Now depending on which measure you get, that's going to help us classify the angle according to its measure. So since this one is 35 degrees, and that's less than 90 degrees, this is an acute angle. Any angle that is less than 90, so anything below this, anything in this range here, okay, from 0 up to 90, okay, all those are acute angles. If we have one that is exactly 90, we call it a right angle. Now, the thing about geometry is, just by looking at this picture here, it looks like it's a 90-degree angle. But until I measure it, or I'm told that it's a 90-degree angle, I can't assume that it's exactly 90 degrees, because this could very easily be 89.9 degrees. Or maybe it's 90.001 degrees, okay, which is not exactly 90. And if it's not exactly 90, it's not a right angle. But they came up with this symbol, this little square that they put in the right angle. That marks an angle as a right angle. So anytime you have this little square in an angle, it's a right angle. Okay, sometimes they'll have angles that aren't drawn very well. Okay, but they'll show the square in there. That is still a right angle, even though it doesn't look like one. It's got the mark telling you it's a right angle. That means it's a right angle. Okay, if we go bigger than 90, then it's called an obtuse angle. Obtuse is anything that's between 90, but it has to be less than 180. Okay, so anything in this range. Okay, these are all obtuse angles. Okay, and then if we go up to a straight angle, okay, that's exactly what it's called. It makes a straight line. So if we get an angle that is 180 degrees, that's called a straight angle. 180 degrees exactly. Something to know about measuring angles. We always want to measure the small part of the angle. Okay, so we're never going to measure this when we're talking about angles. When we get to circles, when we're talking about central angles and how they relate to arcs, then we might use this. But when we're talking about anything besides circles, we don't want to talk about those angles. We always want to talk about the small one, this one. We would measure that one. Same thing here, we would measure this one. We would not measure this angle. Okay, because we want all our angles to be between 0 and 180 degrees. So we can classify them according to the names that we've said. Acute, obtuse, right, and straight. We have no word or term for anything that's above 180, which is another reason we want to stick to the ones that are between 0 and 180. Okay, next, we're going to look at how we name angles. So there's two ways to name angles. There's one that works every time. You can always use 3 letters to name an angle. Okay, when you're using 3 letters, you just have to tell the person. Okay, you always want to imagine you're trying to describe the angle to somebody. You just tell them where it starts, where it turns, and where it goes towards. So let's say I want to talk about this angle right here. I'm going to use 3 letters. I need my angle symbol. It starts at A. It turns at B. Goes towards C. Okay, so that's how you do it with 3 letters. And you can change these around. So you could say, okay, it starts at C, turns at B, and points towards A. Key thing to remember is your vertex has to be the middle letter. Okay, so B, when I'm talking about this blue angle, is going to have to be the letter that's in the middle. If I talk about another letter in the middle, okay, that would tell people that that's where the angle's turning. So if I switch this up, instead of angle B, A, C, that's going to be an angle that isn't actually pictured on here, okay, because that's going to be an angle that goes from B up to A and down to C. Okay, and that one's not on here. But that would be the angle you're talking about if you say BAC. Take that off there. Okay, now, sometimes you can use 1 letter to describe an angle. If there's only 1 angle at a point, you can use 1 letter. For example, that would be B here. There's only one angle at B. Okay, there's only the blue angle. Like I said, we wouldn't talk about this angle here. So since there's only one angle there, I can just call it angle B. Now compare that over here at C. Okay, at C, there's not just one angle. So if I said angle C, you wouldn't know if I meant this angle, or this angle, or even the straight angle. So that's why when there's more than one angle there, you can't use one letter. You have to use three letters. So if I wanted to talk about the blue angle over here, I would have to say angle DCE or angle ECD. The green would be angle DCB or angle BCD. And the red one would be angle BCE or ECB. You have to use three letters when there's more than one angle there. The first way the angles can be related to each other is if they're what's called adjacent. Adjacent, the word adjacent means next to. So you can kind of picture the ones that would be next to each other. If I go up and talk again about this blue one and this green one, they're right next to each other. A more formal definition says that they share a side but do not share interior space. So if you look at the blue and green angles up here, the side that they share would be CD here. Okay, this is a side of the green angle and a side of the blue angle. So they're sharing that side. That side is helping to make up both angles. So that would mean that they are adjacent. Okay, now notice it says they do not share interior space. So if I were to look at another couple angles that share a side, like BCE and DCE, so that would be the red angle, okay, the red one, and the blue one, together, this side right here, okay, CE, is making both of those angles. It's making the straight angle, okay, it's also making this smaller blue angle. But they are sharing interior space, because this is all interior space of the blue angle, and all of this is interior space of the red angle. So since they're sharing that interior space, they're not next to each other. You can tell the blue one is actually inside of the red angle. Those are no longer next to each other, they're kind of inside. The protractor postulate is something that we have. It just kind of reemphasizes the fact that all our angles are going to be between 0 and 180 degrees. We won't really do much with this, but it's something that they have to put out so that we can measure our angles. Okay, there's a angle addition postulate. I'm going to try to put the whole thing up here so you can kind of see what it looks like. So there's these points R, S, and T. Okay, and the angle addition postulate says that if P, so this point here, is somewhere inside this angle, okay, anywhere inside, then if we measure this angle RSP, that would be made by connecting S to P. If we measure this red one, and then we add it to the measure of this blue one, then those two measures together are going to equal the measure of the whole thing, which is the green one. Now there's a little notation here. You can notice I've got this angle symbol again. When I just have the angle symbol, this is talking about the picture. Okay, so angle RST, they're talking about this actual picture of the angle. Okay, they're saying that angle if it's got the m in front of it, they're talking about the measure of the angle. So they're not talking about this red angle, they're talking about how many degrees that red angle is. So this is really a number. Okay, when you've got the m in front of it, that represents a number. So if I take that number, let's say it's, 30 degrees, okay, that means this is 30 degrees. This is 40 degrees. That means that this is talking about the measure of the blue angle, which is 40 degrees. And together they're going to add up to be the measure of the whole thing, which would be 70 degrees. There's another notation thing. If we have angles that are the same measure, we can say that they're congruent. And just like we had a shorthand for our segments, we want to be able to mark those so that people can see quickly, without having to read anything, that they're congruent. So if you notice, these blue ones have the same marking in their angles. So that means that those angles will be congruent. Let me put some letters on here so you can see how you would write that. This is A. We'll make this B, C, D, and then this point can be E. So if I'm talking about the blue ones, I could say angle A, E, B is congruent to angle D, E, C. I could also say that their measures are equal to each other. Just remember, now that I have the m in front, I'm talking about a number. And numbers are equal. Figures are congruent. Okay. And that's the end of it. I went through the protractor thing. So here's the assignment that we had from this section. Okay, so if you get through the minimum, which is the top part here, and you feel like you still don't have a great grasp on it, maybe you checked in the back and they had some different answers than you did and you can't figure out why, go ahead and look through the section, some of the reading in front of it. Watching this lesson again is a good idea. Or go ahead and do some extra stuff until you feel confident in what you're doing.